All right, today we're going to start looking at inverse trig functions. So in this first part, we're going to talk about right triangle, trig, and calculator examples. And in this part, we're going to just consider the angles that are strictly between 0 and 90 degrees. In other words, the angles you would see showing up in a right triangle other than the right angle itself. So recall, sine and cosine, they both take in an angle between 0 and 90, and they spit out a number between 0 and 1. And that makes good sense because when you're looking at the sine and cosine, you're looking at the ratio of either the opposite to the hypotenuse or the adjacent to the hypotenuse. And the hypotenuse is always the longest side, so it's always going to give you something that's between 0 and 1. Tangent takes in an angle between 0 and 90, and it spits out some positive number. And that number can grow without bound because tangent is the ratio of the opposite to the adjacent side. And by making this angle over here get really big, you can make that grow as big as you want. So the inverse functions just undo those things. So inverse sine, inverse cosine, and inverse tangent, they undo the trig functions. Now there's also inverse cosecant, inverse secant, and inverse cotangent. And we're not really going to talk about those that much. The sine, cosine, and tangent are the ones that are going to be the most important. So inverse sine and inverse cosine, they take in a number between 0 and 1, and they spit out the angle between 0 and 90. And inverse tan will take in any positive number and will spit out an angle between 0 and 90. So what I want to do is just first a couple of silly little examples using a calculator here. So right here, use a calculator to find the angles to the nearest tenth of a degree. All right, so on this A here, we've got theta, and we're given the opposite side and the adjacent side. So what I could say here is tan theta is 2 over 4, or 1/2. Now what I can do is I can take the inverse tan of both sides. Let me slide this over. Whoop, I don't want to make it bigger. I want to slide it. Just let me write it again further over. So tan theta is 1/2. What I can do is I can take the inverse tan of both sides. And over here, the tan and the inverse tan, they undo each other. So I'm left with theta is inverse tan of 1/2. And I'm just going to use my calculator to give me that. Now, you got to make sure I'm in degree mode. But the way you do that is you use the second and tan button. Let's see, mode. Yeah, I'm in degrees. Most of you guys probably know how to do this, but you know, if you look at calculators on the sine, cosine, and tangent buttons, the second functions up here are inverse tan, inverse cosine, and inverse sine. Sorry, that might be a little blurry. So anyway, I'm just going to do inverse tan of 1/2, and this should spit out some number. Yeah, 26.56. So what did I say there? To the nearest tenth of a degree. So this is going to be 26.6 degrees. And then over here, if you look at this one on part B, relative to theta, we've got the adjacent and the hypotenuse. So cosine of theta is 15 over 20, so that's 3/4. Take the inverse cos of both sides. And so I just get theta is inverse cosine of 3/4. And do the same thing on my calculator. Inverse cosine of 3/4 is 41.409. And so 41.4 degrees. So really, it's just kind of a reverse lookup, giving you the angle that has that number as its cosine or tangent or whatever. A little thing about notation. The notation that's used here, like up here where you've got tan inverse of x, that causes problems sometimes because people see it and they think that it means 1 over tan x. But don't make that mistake. 1 over tan, that would be cotan. The negative 1 up here, it's the same as like when you say f inverse of x to indicate the inverse function, not the reciprocal. So some other notation for this is also called the arcsine, arccosine, and arctan. So for instance, arcsine and inverse sine, they're the same thing. And also, if you ever need to program this stuff into a spreadsheet or a programming language, most of the time the names for these things are a sine, a cosine, and a tan. So just if you're ever using a spreadsheet or a math package in like Python or something like that, it's usually called a sine and stuff. All right. So on that part, we really just talked about right triangles. We also need to talk about this in general. And I think I want to, I'm going to wait for the next video to talk about the general inverse sine, inverse cosine. So anyway, I'll stop here.